Example 1, Atlantic hurricanes. There have been 652 Atlantic hurricanes during the 118-year period starting in 1990. Assume that the Poisson distribution is a suitable model. For part A, we want to find the mean number of hurricanes per year. Now, the Poisson distribution applies because we are dealing with occurrences of an event, hurricanes, over some interval a year. The mean number of hurricanes per year is the following. It's the number of hurricanes divided by the number of years. So 652 divided by 118 is equal to 5.5. Now we want to find the probability that in a randomly selected year there are exactly 6 hurricanes. We want to find the probability of 6, where the probability of X is the probability of X Atlantic hurricanes in a year. So, the probability of X is equal to 6 hurricanes in a year is as follows, with X is equal to 6, the mean is equal to 5.5, and E is equal to 2.71828. So we're going to use the following formula. The probability of 6 is where X is 6, so we're going to plug it in. We have 5.5, which is the mean, raised to the 6th power, times E, which is 2.71828, to the power of negative 5.5, which is the mean, divided by 6 factorial. So let's go ahead and put this in our calculator. So I have the following. In the numerator, we have parentheses 5.5 to the power of 6, and then shift, and then times 2.71828, and then that's to the power of negative, use the negative symbol, 5.5. Okay, so there's our value there. Now what we want to do is divide it by 6 factorial. So we can either expand 6 factorial, or we can just divide it by, hit 6, and then go to math, and then go to probability, and then go down to number 4 with the factorial symbol, and then press enter. And then we get that value there, 0.157117875. So we get that value here, and then we get 0.157. So another way of doing this is you can expand the 5.5 to the 6th power times expanding that over 720, which gave you that result. So therefore, the probability of exactly 6 hurricanes in a year is probability of 6, which is equal to 0.157. Next, in this 18-year period, there were actually 16 years with 6 Atlantic hurricanes. How does this actual result compare to the probability found in Part B? And does the Poisson distribution appear to be a good model in this case? Well, recall that in the probability of 6, it was equal to 0.157 from Part B, is the likelihood of getting 6 Atlantic hurricanes in 1 year. Now, in 118 years, the expected number of years with 6 Atlantic hurricanes is taken at 118 and then dividing it by 0.157, which gives us 18.5 years. So the expected number of years with 6 hurricanes is 18.5, which is reasonably close to the 16 years that actually had 6 hurricanes. So in this case, the Poisson model appears to work quite well.